Hello, welcome. I'm going to do a little review for the second unit of this class. And we're going to go over binomial distributions. So I'm going to share a few things here on my screen. Alright, so I made a printable version of the online test, and you can find it in the doc sharing section. So here I want to take a look at problem number 6. So we have a random variable x that represents the number of girls in a family with 3 children. Probability of a child being a girl is 42%, 2. Construct a table describing the probability distribution and find the mean and standard deviation. Is it unusual for 8 of 3 to consist of 3 girls? So we have a few things to do. We need to fill this out first. So I'm going to go to my spreadsheet to do that. So probability of a success, a girl being a success, is 42%. Sorry guys, there's a failure here. So spreadsheets, let's see. You could use Excel, you could use OpenOffice, you could use LibreOffice. I am going to use Google Sheets. So I just logged into my Google account, went to my Drive, opened up a new sheet. And so I have X here, which is having 0, 1, 2, or 3 girls. Now, as far as the probability of any of these X occurring, X being number of girls again, I have to use the binomial distribution formula. So there are a couple of ways to do that. I could use the standard formula, which hopefully you have memorized, which says take n factorial, so that would be 3 factorial, and divide that by parentheses, x factorial, which would be 0 factorial, times n minus x, 3 minus 0, times 3 factorial. So remember, the denominator always has to have x in it, and the two numbers in the bottom have to add up to whatever n is. N is 3, the total number of trials. We're trying to have 3 children here. Multiply that by probability of success, which is 42%, raised to the power x, x in this case being 0, times the probability of a failure, which would be 1 minus the probability of success, which should put us at what, 58%? So 0.58 raised to the power n minus x, the other number in the denominator, 3. The 0, 3 in the denominator goes with the powers 0 and 3, success and failure. Now, here I had to type the 0 each time, and I'm referring to that 0 over there. The smart thing to do is, instead of typing a 0 there, to click on the cell the number I want is located in. So I want A2 there. And that's going to be a factorial, so put that back in. Well, the factorial is already there, so let's see, 0. Okay, there we go. And then over here, this exponent right there is really going to be that. Type over, there we go. Number will equal 0. And that 3 there really should be 3 minus whatever's in this cell here, according to the formula. The formula says, is that right? Oops, I'm missing one more thing. I would have to make this 3 here a parentheses. I think it's going to be 3 minus this cell. And that's a complicated formula. Enter. Oh, and I typed it wrong. That sucks, huh? Which means I have parentheses in the wrong spot, or a factorial it doesn't like. So 3 factorial, a2 factorial, minus a2 factorial times 0.24 to the power a2 times 0. Oh, here it looks okay. So the computer doesn't like it. Son of a gun. It should have worked. What don't you like, computer? Oh well. We'll do it the other way. It should have worked. A better way to do it is actually to ask the computer if it has a binomial formula. And it has a binomial distribution formula. So we're going to use that. Number of successes. Yeah. So that's my x. My x is located in A2, so I click on A2. Comma. Number of trials. Well, that's a fixed number. That's 3. Probability of success, 0.42. And is this cumulative or not? Cumulative means we're adding up this x value and everything below it. That's not true here, so it's false. I want to know only about this particular x value, not the whole left tail. What cumulative does. Enter. Okay, so I'm going to double check it by just typing in what I typed before was a 0. So I should have 3 factorial divided by parentheses 0 factorial times 3 factorial. And I'm only doing this to show you the formula works. Times 0.42 raised to the power of 0 times 1 minus that would be 0.58 raised to the power of 3. And it doesn't like that either. Is it freaking out about the 0 factorial maybe? The 0 factorial is technically 1, so we'll just get rid of that. And not either. What the heck is wrong here? Weird. I've never had trouble with Google Sheets like this. All right. So, simplifying, 3 factorial over 3 factorial is 1. So we can narrow down the problem. And that likes it. Huh, it didn't like factorials. Weird. If I go equals 3 exclamation point. Error. Aha! Okay, so something to note. Google Sheets does not accept factorials. You could probably use a factorial formula. FA. Factorial of a number. Oh, FACT. That makes it even more complicated. Well, good thing there's a shortcut formula. Anyway, let's get back to business here. What do we got? We have the binomial dist, and sorry that's kind of small typing. Can read it off to the side. Equals binom. On Excel, it's binom dot dist, but you should see that when you're typing it. Parentheses. Number of successes, that's my x, 0. I just typed on A2 to get that, so that. Total number of trials is 3. Probability of success is 0.42, and then it's not cumulative. I just want a single x value, so that's false. That's what the formula looks like. That leads to the 0.19512. And now if you type that formula with the A2 in the right spot correctly, like I did here, I can then just fill it down and it'll calculate the other probabilities. If this is indeed a probability distribution, then the probabilities above should sum to what? 1, exactly. And there's my 1. So I did create a probability distribution. It's based on 3 trials, and probability of success is 0.42. So those are the numbers I want to put into, fill out this right here. So in your online homework, you'll get the plug of those numbers in there, there, and there, 3 decimal places. Okay, mean. If you're running a TI calculator, you could do the same exact thing in a TI, almost the same exact thing. You only have to type the formula once there. I don't have a TI handy to show you. Call me or email me if you have any questions on that. With the TI, you can just do the one variable statistics on these 2 lists right here, and it'll give you the mean and the standard deviation. Since I'm using a spreadsheet, I'm going to do it my way. So next we're going to do the mean. Calculate the mean, that's what we call the average. Now the problem here is this is going to be a weighted average because I have the numbers 0, 1, 2, and 3, and they're weighted by these probabilities over there. So to weight them, I use what's called the sum product formula. So we'll start off with the equal sign, sum product, cell has the same formula, and then I select my x's, comma, select my probabilities, and it the mean of this distribution is 1.62. So that tells me it is closer to 1 than it is to 2. And if you check out the probabilities, the highest probability occurs with 1. As far as drawing this distribution, that would be the highest stack in the distribution when you draw it. Excuse me. So that makes sense. The mean should be about 1, and that's what we have here. As far as standard deviation goes, on Excel, I have to calculate the deviation, the squares of the deviation. You could just jump right to the squares of the deviation if you want. So to do that, I would go equals. Deviation is always the actual probability. Oops, that's not true. It's the actual x value minus this mean. The deviation means how far are you from the middle. The middle here is mean. And I want to parentheses that and square it. When I fill the formula down, I want the A2 to change to an A3 and so on, but I don't want the B7 to change, so I have to put a dollar sign. My formula here for deviation squared was equals parentheses A2 minus B dollar sign 7. And to do that, I just clicked on B7 and put the dollar sign in between. Put parentheses and square. And then I can fill that down. Now, next thing I'm going to do is I'm going to do a sum product on that. Doing the sum product on that gives me what's called the variance. Excuse me. Allergies are getting to me. Alright, so then we have sum product, the squared deviations equals sum product. Deviations along with their probabilities, and if I take the square root of that, that's what I call standard deviation. So equals SQRT. Here is the standard deviation. Abbreviate STD. So I have the mean and the standard deviation. So we talked about the normal distribution a while ago, and if something is more than 2 standard deviations from the mean, we say that's unusual. Other definition of unusual is if the probability of it occurring or more or less than it, the left or right tail, is less than 5%, and it's unusual. So let's just take a look at what is the mean. We're looking in the upper end, because we're talking about 3 children, plus 2 standard deviations. So I'm just going to go equals this guy plus 2 times this guy, and that gives me a number of 2.96. Ooh, check that out. According to we are just 3 children is just barely above 2 standard deviations above the mean. So according to that rule, 3 children is unusual. Now, the other way to double check is to look at the probability of having 3 or more children. Now, it said error there because I typed equals and I was expecting a formula that was legitimate. I was using equals only to represent a text. So if you want something to be text and not a formula, you put a little hyphen in front of it, and then it treats it as text. So equals, what is that? Probability of 3 or more. And I have to say that because the rule for unusual events is you have to look at a left or right tail. You can't just look at 3, I have to look at 3 or more. Now, the problem here is that I'm only looking at a family of 3, so 3 or more happens to be the same thing as exactly 3. But the coincidence in this particular situation happen to be the same number. Go with it, and we can see that that probability up here is the 0.07. So something to think about. If something is outside of 2 standard deviations, That comes from what we call the range rule of thumb. Range rule of thumb is related to a normal distribution. We learned about that in chapter 3. Now, this isn't a normal distribution. This is a binomial distribution. Is a normal distribution the same thing? Answer is no. That's why they have two different names. I just want to draw this distribution for you. I'm going to use a different program called GeoGebra. Curious about this program. I can show you sometime. Work trials is 3. Probability of success is 0.42. I've used this in some other videos. So here's the binomial distribution for having 3 children with a probability of success for a female being 42%. Let's just stretch it out a little bit more. All right, so it's kind of bell-shaped, but it's skewed a little bit to the right. It's got a longer tail on the right. The skew is always to the tail. This isn't a normal distribution. It's not perfectly symmetric. Okay? The mean is 1, which represents the peak, right? That's what a normal distribution has too. The mean is represents what the peak is, but this isn't normal. So sometimes the range rule of thumb is a little off from the actual situation. But we use it because sometimes it's quicker and easier to look at. So yes, 3 is slightly above 3 girls out of 3 children, slightly above 2 standard deviations from the mean. However, the probability of having 3 or more children out of 3 that are girls is only around 7.4%, which is greater than 5%, which makes it not unusual, not less than 1%. That was exciting, huh? All right, did we beat that problem to death? I think so. Is it unusual? We would go with no, because the probability of having 3 girls is greater than 5%. Let's see, that's not exactly true. No, because the probability of having 3 or less girls is less than or equal to 5%. Oh wow, all of these answers kind of suck. Wow. All right, so having 3 out of 3 girls is not unusual. So it's B or D. The problem is the way this is phrased is incorrect. It should be the probability of having 3 or more girls is less than or equal to 5%. No, that's wrong. Because the probability of having 3 or more girls, it would be B if you replace having 3 girls with having 3 or more girls. It is greater than 5%. So we'd have to go with B here, even though the phrasing is actually incorrect. The others, A, C, and D, are definitely incorrect. All right, let's try another one. How about number 12? I thought that one was cute. Take a look at why. I always think it was cute. 12. Oh, because it relates to candy and it's binomial. Let's see, what do we got? Candy company claims that 12% of its plain candies are orange. And a sample of 200 such candies is randomly selected. Find the mean and standard deviation. Okay, so this is a binomial distribution. We're randomly selecting from a population where supposedly there's a 12% chance of something happening. What happens is we get an orange candy if we randomly select. Okay, so N is 200 and P, the probability of success, is 0.12, 12%. For a binomial distribution, the mean is N times P. So let's use a different program. This program right here is LibreOffice, which is related to OpenOffice, which is like Microsoft Office. So mu equals NP. So for us, N equals 100 on P, probability of success, equals 0.12, and so that means mu equal to N times P, and I can just point and click once I click the equal sign. So mu, what does that mean? Mu is the expected value. Expected value. Expected value is a mean. Expected value means here that I expect about well, here we go, 24 out of 200 candies to be orange. F of percent are supposed to be orange. Okay, so there's that part. We're done. Standard deviation, sigma, that's going to call it FTD for sigma, is equal to the square root, SQRT, of NP cubed. Q is the probability of a failure, 1 minus P. Okay. So as far as the formula goes, STD here going to be equal to the SQRT parentheses of N times P and parentheses 1 minus P. About a spreadsheet, I don't have to figure it out in my head or on a calculator separately what Q is. I can just do it right on the fly. Anyway, just to double check that, if you go off to the side here and say Q equals, and then over here go 1 minus P, 88%. Check there equals the square root of N times P times Q over here. I get the same number. Okay. So the standard deviation is about 4.60-ish, like that. All right, what else do we need to do here with this particular problem? Okay, random sample of 200 candies contains 14 orange. All right, is that unusual? Okay, so when we talk about unusual, we have to say, is it unusually large or unusually small to get 14? Right? Is 14 low or high if we expect 12%? Well, looking back at my spreadsheet, I know 12% of 200 is 24, so I'm expecting to get 24. Right? The problem here is I only got 14. So the question is 14 out of 200 unusually low? I expect 14%. No, was it 12%? Sorry. All right. So how do I figure that out? Well, I spelled unusually wrong. It's a mess, huh? Good at math, bad at spelling. Unusually. All right. So it's certainly low, right? I wanted 24, I got 14. Question, is it really low or is it just a little low? So to figure that out, I have to find the probability of finding 14 or fewer. I'm going to do this. I'll show you another way. Okay, so 14 or fewer. Well, that's a binomial distribution. That means I need to find the probability of 14, 13, 12, all the way down to 0. That's a left tail. Note about that. Left tail probability. That's what the rule for unusual events tells me I have to look at. All right, so let me see. I need a binomial here. B-I-N, binomist, go, and I need x. What's x here? X is 14. Let's see, number of trials, that's n, that's 200. Probability of success, that's 12%. Is this cumulative? Do I want a left tail? Yes, that's true. Those parentheses, enter, that probability is about 1.4%. Is that less than 5%? Less than 5%. Yes, it is. So, what does that mean? S 14 out of 200 is unusually low if I expect that. other way to double check this, since I found the mean and standard deviation, I might as well check to see what 2 standard deviations to the left is. Okay. Now, why am I going to the left? Because 14 is below the mean. So that's why I'm looking to the left. In the last problem, we looked to the right because 3 was above the mean of 1. So I need to figure out what is m minus 2 STDs. So equals the mean, 24, minus 2 times the STD, which is over here, and I get, ooh, check that out, 14.8. And I happen to get just a little bit under that. So according to the range rule of thumb, I'm a little low. So this means 14 is low according to the range rule of thumb. Problem. Range rule of thumb. I shouldn't put that in there. 14 is low according to the range rule of thumb. But the range rule of thumb refers to a normal distribution. Is this distribution normal? Answer, no, it's binomial. Let's take a look at it on the GeoGebra. So, I am going to delete this guy and put in a new one. Binomial distribution, number of trials is 200, probability of success is 12%, and I typed something wrong. What's wrong with that? Invalid syntax. It's right to me. I'm having technical difficulties tonight. Check it out. It's just like before, isn't it? I know. Probability of success is 0.2. Weird. Okay. Let's get a new window here and see if that improves things. Font size equals binomial distribution, 200 trials, 12 out of 100 maybe? Is that better? Huh. Crazy, I don't like that.
Hi, Dad. What is that?
Julia, I'm doing a recording. Excuse me, bud. Okay. Weird. I'll show you now. The program is freaking out on me. Let's use a different example. Problem number 13 had like 764. Probability of success of 0.0104. And I hit that distribution there, and now it will make it. I hate it when that shit happens. Hopefully this doesn't happen to you when you're taking your test. That would really suck. Previous problem had 3 trials, probability of success at 0.042, and I'm just going to shut down GeoGebra because it's not behaving. Son of a gun, don't save, go away. Alright, so I can't draw the picture here, but I can sketch it out by hand. Alright, so my drawing pad, give a normal distribution, let's do that sucker. Alright, so I'm going to draw this binomial distribution. That pen. Alright, so here's my x-axis right there. So, what do we know here? We know that the mean is 24, right? So that's right there. The smallest we can be is over here at 0. Right? Now, if that's 24, oh crap, 100 would be somewhere over here, 200 would be way off the scale, so I gotta move couple things. Let's move this little guy. Let's put 24 there. That right there. Okay. So if that's 24 right there, And let's say 200 is way out here. 200. All right, so the highest probability occurs at the mean. So the tallest stack here is going to be right there, above 24. And then what's going to happen is it's going to drop off towards 0. Now there's really going to be a lot more stacks, so just bear with me here. And then on this side, it's going to drop off pretty quick too. Whoa, that was kind of sloppy. And it's going to disappear. And then these probabilities get wicked tiny out here. So this distribution is shaped something like this. It peaks at 24, and then it drops quickly, and then it has a very small tail out that way. So that's what this distribution is going to look like. And we were calculating the probability of finding 14 or fewer. So let's see. I'm going to use my spray can. That's a big can. Let's shrink that down a little. That's better. So 14 is probably some. Ooh, wow. I didn't expect that to happen. Maybe that's the wrong tool. Just use a big fat pencil. So 14 is somewhere over here. Let's make it red. Oh, crap. I'm hitting all the wrong buttons today. What tool do I want? I want that. Oh, it's because I selected that. Alright, turn that off. Turn that on. Red pen. Alright, there we go. 14 is somewhere over here. Red. This region right there. What a mess. Anyway, so we calculated that probability right here. This distribution, keep in mind, again, goes all the way out to 200, but the density is all around the number 24, because that's the mean. We're looking at 14. I'm just going to try and draw you that with a professional program instead of a hand drawing. All right, so what the hell did we just figure out here? We figured out that having 14 is unusual because it is just a little bit less than 2 standard deviations below the mean. So it's yes, because 14 is greater than the maximum unusual value. No, the maximum unusual value is the other way. 14 is just less than the minimum. Okay, so that looks good. Yes, because 14 is below the minimum usual value. Thus, the claimed rate of 12% is probably wrong. Well, it's just barely below, but I guess we'd have to say that. What else? Yes, because 14 is within the range of usual values. No, it's not. Just to the left. Is it unusual? This says no, it's not unusual because it's within the range. Yeah. So D and C are definitely wrong. A is wrong because we're looking at a min, not a max. So it's got to be B. 14 is unusual because it's a little bit below the minimum unusual value. Minimum usual value, sorry. Minimum usual value, again, comes from being 2 standard deviations below the mean. I only looked below the mean because 14 is less than the mean 24. Didn't need to look above. All right, that's enough for now. I'll be in touch soon. Take care and do good math. Let's see how do I check out over here. There we go. Did it really stop? No. Hello.